The scenes you are about to witness depict fatal accidents that occurred while employees were working in shipyards. All identifying references have been removed to protect privacy interests. Please be advised that the depictions may be disturbing and deal with graphic subject matter. Two men were unloading steel beams from a trailer using a truck-mounted crane. The outriggers on the crane were fully extended and set. The rigger and his helper walked with each load, controlling it with tag lines. The crane operator lifted each load and swung the crane to his right about 180 degrees and lowered the beams to the ground. During the unloading, the foreman approached to talk with the rigger's helper. When the unloading was finished, the crane operator began to put away the rigging and stow the crane. The foreman left, but the rigger's helper remained standing beside the outrigger. As the operator swung the crane into the stowed position, the rigger's helper was crushed between the crane cab and the outrigger he was leaning against. The swing radius of the crane was not barricaded to prevent employees from entering a hazardous zone. The crane operator should have kept visual contact with his helpers at all times. An audible signal should be installed on the crane to warn employees of the crane's movement. A 45-ton hydraulic telescoping crane was being used to move several loads, weighing more than 2 tons each. The crane has a multi-part main line and a single-part auxiliary line. The crane operator had experience operating other cranes, but had no training on this specific model crane. Before beginning, he asked other crane operators how certain controls worked. He did not understand their instructions. He practiced raising and lowering the main hook and extended and retracted the boom for 15 minutes. During this time, alarms were ringing in the cab that the crane operator did not understand. He was eventually able to shut them off along with the anti-two-block system on the computer. A rigger was positioned near the first load to connect the crane's hook. He was inexperienced and undergoing his second day of training. The crane operator extended the boom to put the hook over the load. The lengthened boom put the auxiliary hook and line in a two-blocked condition. As the boom extended, the auxiliary line came under increased tension. The rigger noticed a cotter pin fly off. He looked up, saw the boom wiggle, and turned to run. The rigger was struck and killed instantly by the falling auxiliary hook. The crane operator used equipment that he was not trained to operate. Safety and warning devices were turned off or disabled during operations. Personnel must never work under the boom, hook, or loads. Although not contributing to the fatality, workers working near the water's edge must wear personal flotation devices, or PFDs. Two night shift employees were moving lighting and spray painting equipment inside a barge to continue a painting operation. Employees on the previous shift had been painting in the confined space continually for 10 hours. The paint mixture being used was flammable. The lighting equipment was not explosion-proof. There was no ventilation and only one open access hole. Painters and laborers constantly entered the confined space without any air monitoring. As the two night shift employees set up the equipment, a spark ignited the flammable paint vapors and caused a flash fire. Both employees were killed. Sufficient ventilation would have kept the concentration of flammable vapors below 10% of the lower explosive limit. A shipyard competent person should have visually inspected and tested the confined space for oxygen content and lower explosive limits prior to entry by employees and found the flammable atmosphere. There should be no plugs or electrical connections within 50 feet of hazardous atmospheres and painting operations. Explosion-proof lighting and equipment must be used when spraying flammable liquids. The employer did not make sure that employees entering confined spaces were properly trained to recognize hazards. Although not contributing to the fatality, electrical cords and open access holes presented two additional safety hazards. Electrical cords and painting hoses should not be in the way of workers using the ladder. Clear interference with ladder access as much as possible. Open access holes in decks should be adequately guarded to prevent employees from accidentally falling down them. Employees were cleaning a confined space on board a vessel using solvents. The foreman told them to ventilate the space and dilute any vapors with an air hose. A first shift worker brought in an oxygen hose to ventilate the space. The oxygen flowed into the compartment for 3 hours. A second shift worker entered the confined space smoking a cigarette. He threw the cigarette to the deck and it began to burn like a candle. When he stepped on the cigarette, his shoe and pant leg caught fire. The oxygen-enriched atmosphere caused the fire to increase rapidly, and he was quickly engulfed in flames. He died as a result of the burns he received. The worker ventilated the confined space with an air hose. To make matters worse, the worker used oxygen to ventilate the space. Never use oxygen to ventilate any space. Use a blower or ventilation fan. The confined space was not inspected and tested for air quality and flammability by a shipyard competent person prior to entry. The employee was smoking in an area where smoking was prohibited. Employees should only smoke in designated areas. Employers should place signs where smoking is not permitted. A welder and his helper were installing guardrails on a dock. The work was being done from a smaller barge that was tied to the dock. The smaller barge was moved along the dock as work progressed. The helper would hold a section of guardrail in place while the welder would tack weld it. The welder would come back later and finish the weld. The icy deck made walking and working surfaces very slippery. While the welder was finishing several sections, his helper reached around the corner of the dock to take a measurement. He slipped and fell into the water. The welder heard his helper's call and ran to him. The welder could not reach him and ran to call for help. When the welder returned, his helper had disappeared beneath the water. There were no training programs in place to prevent falling accidents. There were no life rings available to rescue the drowning employee. Life rings with at least 90 feet of rope attached must be available and in the vicinity of the work area. Since few work barges have guardrails to prevent workers from falling in the water, workers on them must wear PFDs or tie off to a secure structure. A ladder should also be available for rescue. An assessment of the work hazards should have been conducted prior to starting work. Not enough attention was given to the icy working surface conditions. Pay attention to work surface hazards and abate them. A welder was erecting scaffolding inside a vessel that was under construction. The welder attached the scaffolding to the bulkhead using bracket clips that are temporarily tack welded in place. The welder was trained and certified to install and weld these type of clips. After he finished assembling the scaffold structure with temporary welds, the welder walked out onto the scaffold boards. One of the bracket clips failed, causing him to fall 18 feet to the deck below. He died from massive injuries. The bracket clips, which require full welds, were only tack welded. The welder should not have climbed onto the scaffolding with tack welded clips. Welds must be inspected before a scaffolding structure is placed into use. The welder was wearing a body harness but did not tie off. Always wear a full body harness and tie off at heights of 5 feet or more. When accessing scaffolds, ladders should extend 3 feet above scaffold boards. A mechanic needed a workbench-mounted grinder and went to the tool room to get one. None were available. He decided to construct a grinder by modifying an electric buffing wheel. He created a mount and attached the buffing motor to the bench. He removed the buffing wheel, installed a grinding wheel in its place, and began constructing a guard. Before the guard was finished, he decided to test the grinder. He plugged it in and turned it on. As the wheel gained speed, it reached a point where the centrifugal force caused the wheel to break apart. The wheel shattered into pieces, striking the mechanic with tremendous force. The mechanic died from multiple wounds to the chest and abdomen. Equipment must never be modified for use other than its intended purpose. Ensure that the grinding wheel is appropriate for the RPM rating of the motor's spindle, and ring test the wheel before it is installed. The mechanic used the grinder without the guard in place. A grinder must have a guard with a properly adjusted work rest and tongue guard. An operator should stand to one side when starting any grinder. An operator must always wear eye protection when using a grinder. A welder was tasked to repair a hole in the hull of a barge. Assisted by 2 other employees, he opened the hatch into the compartment where the repair was to be made. A welding machine was positioned on deck near the hatch. Carrying the welding leads, the welder climbed down to the repair site. The compartment was flooded with 5 inches of water, so he quickly became wet. He inserted a welding rod into the electrode holder. He waded back through the compartment and climbed up to the deck. He turned on the welding machine and went below to repair the hole. He burned the first rod and dropped the stub into the water. He picked up a new welding rod, and as he inserted it into the electrode holder, he completed the circuit between the electrode holder and ground. Current flowed through his saturated glove, through his wet body, out his submerged steel-toed shoes, and into the steel deck he was standing on. The location of the victim inside the barge made rescue difficult. Because no rescue equipment was available at the job site, the fire department was called. They were not trained in confined space rescue. Upon arrival, they found that the victim was beyond resuscitation. A competent person should check the space prior to entry. The water in the space should have been pumped out, or boards should have been placed above the water for the welder to stand on. Do not weld while standing in water. The welder was not properly trained to perform welding operations in wet environments. Employers must ensure their local fire departments are trained to provide emergency rescue. If not, arrangements should be made with other parties to provide this service, or employers need to develop their own in-house rescue team. Open access holes in decks should be adequately guarded to prevent employees from accidentally falling down them. We urge you to think about the accidents you just saw and to use that information to make your job safer. Don't add your name to the list of fatalities. And remember, all shipyard workers must wear or use equipment necessary to protect them from occupational safety and health hazards. Such equipment may include hard hats, safety glasses, protective footwear, gloves, long-sleeve shirts, long pants, hearing protection, and a flashlight or light stick. If you are asked to perform a task that you believe is unsafe, or you are asked to perform a task in an unsafe manner, or in a manner that violates OSHA regulations, ask your supervisor or employer for help in determining the correct and safe way to proceed. You can also contact your local OSHA office for help or visit the OSHA website at www.osha.gov. Employers can request a free on-site consultation visit and obtain additional information by contacting their local OSHA office or through the OSHA website. If you have an emergency, need to report a fatality, or a workplace hazard that poses a threat to health or safety, or want to file a complaint, please call OSHA's toll-free number, 1-800-321-OSHA. The scenes you're about to witness depict fatal accidents that occurred while employees were working in shipyards. All identifying references have been removed to protect privacy interests. Please be advised that the depictions may be disturbing and deal with graphic subject matter. A crane operator and 2 riggers were moving structural sections of a crane boom from a storage area to another area of the shipyard. The riggers were positioned at both ends of the structural sections while they were being transported. After the first section was delivered, the men noticed their original route taken to deliver the first section was now blocked by another working crane. Rather than wait for the crane to finish and move out of the way, they decided to take another route to the worksite. As they transported the second section, the 2 riggers focused their attention on keeping the load headed straight down the narrow path. All 3 workers failed to see the overhead power lines. The crane boom contacted these high-voltage power lines. 7,200 volts passed from the power lines through the wire rope into the suspended structural section to the rigger, who was still holding on to the section. The rigger was killed instantly. Let's look at some of the contributing factors that led to this fatality. En route to their work area, the crane traveling with the suspended load struck overhead power lines. A safe route was not established before the crane was moved. A designated person must establish a safe traveling route for cranes. Equipment must not be operated or positioned within 10 feet of an energized power line. The rigger holding onto the load provided an electrical path to ground. Always use non-conductive tag lines to control loads. When practicable, tag lines should be clean and dry. Riggers assigned to assisting the movement of the crane and load must ensure sufficient distance is maintained between the extended boom of the crane and power lines. Ensure riggers are adequately trained to recognize crane hazards. It is recommended that power lines be clearly marked and visible, as well as other overhead hazards. If workplace conditions change, another hazard assessment should be performed to determine whether previously unidentified hazards exist. Although not contributing to the fatality, it is recommended that loads be carried no higher than necessary, normally waist high, to prevent contact with any other obstruction. A truck crane lifts steel shell plates from a staging area. The crane holds them in place on the vessel while they are tack welded in position. After tack welding several steel shell plates, the welder went back to complete the welds on each plate. As the employee completed each weld, the crane continued moving additional plates into position. As the welder worked on the port section, the crane moved plates to the starboard side. The crane lifted each plate and swung it over the hull under construction. The crane operator inadvertently left the auxiliary hoist line partially extended. As the crane swung, the auxiliary line struck the top of a shell plate, snapping it at its tack-welded base. The shell plate toppled and fell onto the welder working below. The welder was crushed to death. Let's look at some of the contributing factors that led to this fatality. The crane operator did not recognize the hazards caused by the partially extended auxiliary hoist line. Crane operators should assess and recognize potential hazards before starting work. Unused slings and lines must be secured prior to moving the load. The crane operator swung the boom and load over an area where the employee was working. Crane operators must never swing loads over employees. The work should be planned and plates pre-positioned on both the starboard and port sides so there is no load passing over the workers. It is recommended that riggers wear a high visibility vest and have available to them an audible device such as a whistle to alert crane operators or nearby workers of unsafe situations. The welder was not aware that the crane had started to swing over his work area. Educate all workers of the hazards around working cranes. Crane operators should keep visual contact with nearby workers. Assign a spotter on the ground to make sure the crane will not interfere with other objects or other work operations. An inactive ship was being prepared for relocation to another pier. 2 men were rigging a chainfall to lift the last of 7 3,000-pound mooring chains in order to secure it along the deck edge of the vessel. One half of the mooring chain was supported part of the way up the side of the vessel. The men were preparing to lift and secure the unhooked end of the mooring chain near the deck edge. The men began by attaching several short wire rope slings end to end with shackles, creating a longer hoisting line. One end of the sling assembly was attached to the unlinked end of the mooring chain. The other end of the sling assembly was led through a bit on the deck edge of the vessel and then attached to a chainfall. As the chainfall pulled its maximum distance, the sling assembly was secured to the bit by manila rope, used as a stopper. The chainfall was then slackened so that the chainfall hook could be attached to the next sling shackle through the bit. As the second sling was pulled by the chainfall, the sling shackle got hung up on the bit. The sling assembly was secured with a manila rope stopper, and then the chainfall was backed off. While waiting for instructions, the worker walked into the area and looked over the deck edge to see what was wrong. The manila rope stopper snapped, causing the weight of the chain to be transferred back to the sling assembly. The slack assembly suddenly became taut and struck the rigger in the neck with tremendous force, breaking his neck. The rigger died instantly. Let's look at some of the contributing factors that led to this fatality. A hazard assessment was not performed before the work began. Riggers were not properly trained to perform the tasks they were assigned. The sling assembly used was not properly sized for this hoisting operation. For this job, only slings that fit through the bit should have been used. A safety line should have been attached to the end of the mooring chain to support it if the hoisting apparatus failed. Always use the proper equipment for the job. The employee entered the bight of the line while the line was under load. Never enter the bight of the line. The crew relied on manila rope as a stopper. The load on the rope exceeded the safe working strength of the rope. Never exceed safe working loads of rope, line, or chains. Two workers were assisting a crane operator who was loading a piece of equipment from a pier onto a ship. The ship's crane was being used to transfer a heavy delivery valve onto the ship for installation. The workers were positioned on two unguarded catwalks that ran along each side of the ship's open hopper. The workers used tag lines to guide the load onto the ship's deck. As the crane swung the load from the pier to the ship, the load disengaged from the hook. The load fell and struck the starboard side catwalk near one of the workers. The startled worker on that catwalk quickly stepped back away from the falling load and lost his footing and fell, hitting his head on the catwalk as he went down. Unconscious, he fell into the hopper, which at the time was filled with water, and drowned. Let's look at some of the contributing factors that led to this fatality. The valve was not properly rigged to the hook of the crane. Always ensure that the load is properly rigged to prevent the load from becoming disengaged from the hook. It is recommended that hooks be equipped with a safety latch or moust. Actions were not taken to ensure adequate fall protection was provided to workers along unguarded edges. Employees working on elevated catwalks must have adequate fall protection. In required order, such protection includes guardrails, fall arrest systems, or if employees are working over water, personal flotation devices. A dive team was asked to install J-bolt patches as a temporary repair for two holes in a crude oil tank barge. The two holes were at a depth of approximately 25 feet. The dive team consisted of two scuba divers and a diving tender to control the safety lines from the pier. The two divers entered the water to remove a wooden plug from the first hole and install a J-bolt patch. Both divers had safety lines attached. After installing the patch, both divers returned to the pier and exited the water. Diver number 1, wearing blue, remained on the pier, while diver number 2, wearing yellow, re-entered the water by himself to tighten the first patch that was installed. Diver number 2 had a safety line attached for this dive, but the line was not tended. After tightening the patch using a pneumatic wrench, diver number 2 exited the water. On his third dive, diver number 2 re-entered the water by himself to move the air hose, safety lines, and magnets from the location of the first patch to where the second patch would be placed. The air hose and safety lines were attached to the hull of the ship with a magnet. Diver number 2 did not have a safety line attached because he was relocating it. Diver number 2 had been in the water for over 10 minutes, while diver number 1 was on the dock mixing epoxy. He called the tender off his break to help him with preparing a patch for the second hole. When the tender returned to the dive location to assist diver number 1, he noticed that the air hose and safety lines were not attached to the hull, indicating that diver number 2 failed to reattach the lines. He became suspicious that something was wrong. Diver number 1 put his scuba equipment back on and entered the water to find diver number 2. Visibility was very poor, so diver number 1 could only search by feeling with his hands. After a search of approximately 10 minutes, diver number 2 was found unconscious and was removed from the water. Diver number 1 attempted to resuscitate diver number 2 by performing CPR. His efforts were not successful. Let's look at some of the contributing factors that led to this fatality. While in the water, scuba divers must always be tied to a safety line and line tended from the surface, or accompanied by another diver with continuous visual contact at all times. A standby diver must be ready to provide assistance whenever a scuba diver is in the water. Scuba divers must carry a reserve air breathing supply. When line tending from the surface, a tender must never leave his post. The designated person in charge must not let other tasks detract from his prime responsibility, the safety and health of dive team members. Two workers were told to pump out the bow compartment of a barge that held 12 inches of water. The on-deck pump they would normally use was being repaired, so they decided to use a smaller gasoline-powered pump inside the compartment. The compartment had only one open access hatch that the workers used to enter the space. The gasoline-powered pump was set up inside the space, and one worker remained with it to make sure that the intake hose stayed submerged. Exhaust gases from the gasoline-powered pump containing carbon monoxide built up in the space. The workers slowly became unconscious and eventually fell face down into the water that remained in the space. The other worker on deck did not know there was a problem because the pump was running continuously. Later on, when the pump ran out of fuel and stopped running, the worker on deck went down into the compartment and found his co-worker face down in the water. Let's look at some of the contributing factors that led to this fatality. Confined spaces must be visually inspected and tested by a competent person to determine the atmosphere's oxygen content prior to an employee's entry. Employees entering confined or enclosed spaces must be trained to perform their work safely and to recognize hazards. When using internal combustion engines exhausted below decks, the space must be periodically tested by a shipyard competent person to ensure that dangerous levels of carbon monoxide do not develop. Ventilation must be provided to maintain the oxygen level and keep carbon monoxide below hazardous levels in spaces where internal combustion engines are used. Workers in confined or enclosed spaces or in isolated locations must be checked frequently. An electrician was working on an open electrical panel on a ship. He needed to add a new cable and attach it to a breaker within the panel. The electrician identified the isolation breaker that fed the entire panel on the schematic drawing. The electrician de-energized the breaker and properly tagged out. As the electrician was fitting the new cable into the panel, his left hand came into contact with the panel's main bus bars. 440 volts of current passed from the bus bars through his left hand, across his chest, and out his right hand that braced him against the panel, electrocuting him. At some point, the tagged-out isolation breaker had been cross-wired with another breaker. The electrician did not know that the panel he was working on was never de-energized. Let's look at some of the contributing factors that led to this fatality. Employees should verify the location of all energy isolation points. Employees must check or test electrical panels or electrically powered equipment to ensure they are, in fact, de-energized before working inside them or within the vicinity of exposed electrical circuits. Inform all contractors and subcontractors of the ship's systems and/or modifications to the systems prior to beginning work. A shipyard worker was preparing to replace a high-pressure steam valve that was faulty and leaking in an engine room. The valve was part of a 600 psi steam system on a vessel. Other shipyard personnel had previously located all the valves and drains and isolated the steam system according to the ship's as-built drawings. All the drains indicated on the as-built drawings of the ship were opened and depressurized. The drains were then marked with tags. As one of the workers loosened the bolts around the faulty valve, a tremendous burst of steam was suddenly released. The steam under high pressure at 385 degrees Fahrenheit knocked the worker to the ground and produced third-degree burns on more than 60% of his body. The worker died 2 days later in the hospital. Errors and omissions on the ship's as-built drawings had prevented shipyard personnel from completely isolating and draining the steam system. Let's take a look at some of the contributing factors that led to this fatality. Use a thermal gun or carefully place your hand near both sides of the valve to check the temperature. Verify that the steam system is drained and the drain valve is open. Be careful not to touch the pipes or valve too quickly. Approach them slowly to feel if heat is radiating from them first. If they are very hot, then they may still contain steam under pressure. Accurate drawings free from discrepancies are essential for effective energy isolation. Shipyard personnel should be properly trained to conduct a visual check of all drains and valves in a steam system that is to be drained and depressurized. Drain connections on all dead interconnecting systems must be opened and observed to ensure effective isolation. Employees authorized to perform steam system repairs should be directly involved in the isolation and lockout-tagout of the system. Direct involvement by workers in the lockout-tagout process ensures their understanding of the operation or process hazards that the lockout-tagout is designed to control and how to avoid or control these hazards. It is essential for ship's personnel and repair contractors to communicate and coordinate about the isolation and lockout-tagout of the ship's systems. We urge you to think about the accidents you just saw and to use that information to make your job safer. Don't add your name to the list of fatalities. And remember, all shipyard workers must wear or use equipment necessary to protect them from occupational safety and health hazards. Such equipment may include hard hats, safety glasses, protective footwear, gloves, long-sleeve shirts, long pants, hearing protection, and a flashlight or light stick. If you are asked to perform a task that you believe is unsafe, or you are asked to perform a task in an unsafe manner or in a manner that violates OSHA regulations, ask your supervisor or employer for help in determining the correct and safe way to proceed. You can also contact your local OSHA office for help or visit the OSHA website at www.osha.gov. Employers can request a free on-site consultation visit and obtain additional information by contacting their local OSHA office or through the OSHA website. If you have an emergency, need to report a fatality, or a workplace hazard that poses a threat to health or safety, or want to file a complaint, please call OSHA's toll-free number, 1-800-321-OSHA.